Hi everyone. Today we are going to talk about percent error. So scientists often express their uncertainty and error in measurement by giving a percent error. Okay, and then I give you the formula to find percent error. Remember, there are absolute values. So your percent error will never be negative, it will always be positive. You will take the actual value minus the measured value, divide by the actual value, and then multiply by 100. So whenever you are typing this into your calculator, you need to make sure you break it apart into 3 steps. You subtract, you need to hit enter, then you divide, hit enter, and then you multiply by 100 and hit enter. Okay, you need to break it down into 3 steps or else you will get the wrong answer. Okay, I am going to go through this first problem with you. Number 1, while doing a lab, a student found the density of a piece of aluminum to be 2.85 grams per cubic centimeter. The accepted value for the density of aluminum is 2.7 grams per cubic centimeter. What was the student's percent error? Well, the first thing you need to do is figure out which value is measured and which value is the actual. So, the actual value of aluminum, the accepted value, is 2.7. Okay? The measured value is what you do in lab. Okay? So the student found the density to be 2.85. That is what they measured it to be. Okay? I highlighted the numbers for you so then you can plug it into the equation from above. So let's go ahead and plug it in. You're going to take your actual value, which is 2.7, and subtract the measured value, which is 2.85, divide by the actual, which is 2.7, and then you'd need to times by 100. Okay? Go ahead, pause the video, type this in your calculator, and remember to break it apart into 3 different sections. Okay, once you typed it in your calculator and you broke it apart into 3 sections, you should have got a percent error of 5.6, and make sure you label it with a percent sign. Okay, that is the unit we are working with here. Okay, whenever you are writing your number in percent error, I would just like for you to round to 1 decimal place. Okay, that is good enough for me. So let's go ahead and move on to the second problem. A student measured the specific heat of water to be 4.29 joules per gram degrees Celsius. The literature value of the specific heat of water is 4.18 joules per gram degrees Celsius. What was the student's percent error? So again, we need to figure out our actual value and our measured value. So our actual value, the literature value, is 4.18. Okay? What we measured it to be in lab is 4.29. So again, just take these numbers and plug it into the equation given to you. And yes, you do need to remember this equation for your test. Okay? It will not be given to you. So just a helpful reminder, it actually does not matter which one you subtract first. Okay, you could take measured minus actual, but you do always have to divide by that actual value. Okay, so you can flip the top as long as you always divide by the actual, you will get the correct answer. So let's go ahead and flip it for this problem just so you can see what I'm talking about. So we can take 4.29 minus 4.18 as long as we always divide by that actual number, which is 4.18. And our last step is to times by 100. Okay? So go ahead, plug this into your calculator, break it apart into 3 steps. Subtract, hit enter, divide, hit enter, times by 100, hit enter. The number you should have got would be 2.6, and make sure you label it with a percent sign. Okay, that is your final answer. So again, if you're in your test and you can't remember which ones you should subtract first, it does not matter as long as you remember to always divide by that actual number and then times by 100. Okay, let's go ahead and look at the third one. A student took a calibrated 200-gram mass, weighed it on a laboratory balance, and found it to read 196.5 grams. What was the student's percent error? Well, if it is calibrated to 200 grams, that is the actual value. Whoops. $200 is our actual value. Did I highlighted that wrong? Okay. Our measured value is going to be what we do in lab, and we got 196.5. Okay, so again, we plug this into our equation. Remember, it does not matter which one you subtract first, as long as you always divide by actual. So I'm going to take 200 minus 196.5 divided by 200. Always divide by the actual. And your last step is to times by 100 to put it in percent. Okay, go ahead, plug this in your calculator. Do not forget to break it into 3 steps. Okay, and you should have gotten 1.75. Remember, I just want one decimal place, so you can round that up to 1.8%. Make sure you label it. Okay, number 4. A block of wood has the dimensions of 50 times 10 times 5. A student determined its volume to be 2,490 cubic centimeters by measuring the volume of the water displaced by the block when it was immersed in water. What is the percent error in the student's determination of the volume? Okay, well, we know the student determined it to be 2,490. Okay, so this is going to be my measured value. My actual value is all of these numbers. Okay, we need to find the actual volume. So to find volume, remember the equation is length times width times height. So we need to take 50 times 10 times 5. Okay, whenever you do that, you should get 2,500 cubic centimeters. Okay, and that is my actual value. So plug it into your equation. 2,500 minus 2,490 divided by actual. Always have to divide by actual. Last step is to times by 100. Plug it in your calculator. Your answer is 0.4%. 0.4% error. Okay, one more problem we are going to do, and then you have the rest of the time to finish the independent practice over percent error. So, looking at this problem, the true value of the boiling point of methyl alcohol is 65 degrees Celsius. When you measure the boiling point of methyl alcohol, you get 66 degrees Celsius. What is the percent air? Okay, the actual boiling point, the true value, is 65. When you are in lab, you measure the value to be 66. So again, plug this into your equation. Okay, I am going to take 66 minus 65 because I do not want to get a negative number. Remember, it does not matter which one you subtract first as long as you always divide by the actual. So I need to divide by 65 times 100. Plug that in your calculator. You get 1.54. That rounds to 1.5%. Okay, always make sure you are labeling your numbers with a percent sign. Okay, if you have any questions, please feel free to reach out to me. And you have the independent practice to complete now. Okay, the independent practice can be found below the notes.